Welcome to Chapter 3, Day 1. This whole chapter is going to be... There we go. This whole chapter is going to be about parallel lines. It's going to be about angle relations and angle locations. As well as towards the end of the notes, we've got some theorems coming up. Now this video especially, but this whole chapter, is going to be very, very vocab heavy. So as you can probably see looking at your notes, we were starting this PowerPoint off with a whole bunch of vocab. So make sure you label your pictures clearly and make sure you have your flashcards ready to roll. That being said, let's get started. Now the first thing we're going to do is describe our angle locations. Okay, remember that word, angle locations. These are just the names of where the angles are. Okay, and whenever you have two lines, or two or more lines that are intersected by a transversal. So two or more lines intersected by a transversal, these are the locations that come up. Now a transversal is this line. It is the line that does the intersecting. When you go to look for these angle locations, find your transversal first, because all of these are going to be around the transversal. And the names used to describe these locations actually involve the transversal. So knowing what your transversal is very important. So here we go. Number 1. Angles 3, 4, 5, and 6 are all considered what kind of angle? So here we have 3, 4, 5, and 6. Okay, so we have our transversal, and then we have our two lines. So notice how all of these highlighted angles are inside the two lines. Okay, but they're between each of the two lines. We call these angles interior angles, because they are in between your two lines. Now likewise, angles, let me use a different color. Likewise, angles 1, 2, 7, and 8, well, those are on the outside of our two lines, of line 1 and line 2. So we call those exterior angles. Moving on, the next one, let me erase these. The next one is angles 1 and 5. So here we have angle 1, and here we have angle 5. Now as we look at these, notice how you could almost like draw a box. Like they're both angle 5 and angle 1 are both in the same upper left corner of this box type thing. Okay, they're both in the exact same position in their relative clusters. These are called corresponding angles. Corresponding because they're in the same position. Okay. Now there are 3 other pairs of corresponding angles. Go ahead and find them. And here are the other 3 pairs. As we go through this, make sure you're paying attention. All of these names are based on where the angles are in relation to the two lines, and as we're about to get started in, the transversal. So when in doubt, if you forget what something's called, just describe where it is, and that should get you pretty close to what you're talking about, or what you need. Now the next two, we have angle 3 and angle 6. So angle 3 is right here, and angle 6 is right there. Now right off the bat, those are 2 interior angles. They're inside the two lines. So we already know they are interior angles. But notice how angle 3 and angle 6 are on either side of the transversal, on opposite sides of the transversal. 3 is on the left side, 6 is on the right side. So they're on alternate sides of the transversal. Therefore, this angle is called alternate, or this angle relation. These angles are called alternate interior angles. Go ahead and find the others. In this case, there's only two others, 4 and 5. Still inside our two lines, but on either side of the transversal. The next one is 1 and 8. Very similar to this one, or very similar to 3 and 6. We have 1 and 8. Now they're still on opposite sides of the transversal, so we still have an alternate angle pair. They're on alternate sides of the transversal, but these are outside our two lines, so these are going to be alternate exterior. Go ahead and find the other one. Angle 2 and angle 7 are the other pair of alternate exterior angles. Right. Here we go. I'm going to try to keep the picture inside of the frame. Last two, we've got angle 4 and angle 6. So angle 4 is right here, and angle 6 is right here. Okay, these two are inside, they're interior angles. So we already have interior angles, and notice how they are on the same side of the transversal. So you could call these same side interior. Go ahead and find the other pair. Now, if you've noticed the pattern, we've had alternate interior, alternate exterior. We're going to have the same thing here. We have same side interior, and then we have for angles 2 and 8, we have same side exterior. Go ahead and find the other two pairs. And there they are. As a bit of a side note, same side interior and same side exterior, depending on what you're reading, what you're looking at, they also could be called consecutive. Okay, so consecutive interior or consecutive exterior. For the most part, I'm going to be using same side. That's just the vocabulary I'm the most comfortable with, but so that you're aware, whenever you see the word consecutive, it's talking about same side. What I want you to do is take a moment, and in your notes, solve these 5 through 8 questions down here. And go. And here are the answers. Now keep in mind, no matter what your picture looks like, no matter how it changes, how many lines are involved, whatever, always look for the transversal and look for your two lines. Okay, that's how you're going to be describing the locations and describing your angle relations. Because these are a relationship. The primary question whenever you are going to name these angles is how do they relate to each other. Now before we move on to the next slide, there's a few other vocab words we have to go over. This time, they are vocab words pertaining to our lines. So first, we have intersecting lines. Then we have parallel lines. Finally, we have skew lines. Now, you probably know what the first two are, but we're going to define them anyway so you have the technical correct way these are going to go. Intersecting lines are, as we learned in the first chapter, two lines that intersect. Okay? Now, these can be on the same plane. They can be on different planes. So, as an example of same plane, coplanar lines, if you have something like that, they could be intersecting right there. Or you could have coplanar or non-coplanar lines that intersect when you've got something like that. And that second line's going up and down. Parallel lines, now you all know the middle school definition, hopefully. middle school definition that the parallel lines are two lines that don't intersect. I'm going to add on to that. We have two coplanar lines that don't intersect. Okay? Two coplanar lines that never intersect. So make sure that when you're looking for parallel lines, are the two lines coplanar. Now skew lines are two non-coplanar. That never intersect. And the best way to visualize skew lines is to think of a cube. So if I were to draw my cube, parallel lines would be two sides of the same cube. So here and here. Okay, or you could go these sides right here. They go on forever and they never, ever, ever intersect. However, if you wanted to find, and I'll use a different color so you can see, if you want to find skew lines, you would be looking at, say, this line and this line. Okay? No matter how far those lines extend, they will never intersect. Two non-coplanar lines that never intersect. Alright, I'm going to pick up this pace a little bit. And we're going to talk about the angle relations once we have parallel lines. Because stuff gets more interesting when the lines are parallel. Alright, so look at this picture. It's already labeled for you, and what's been labeled are the vertical angles. So I'm going to throw in some numbers to help you see it a bit better. Let's say that A is 80. Well, that means that C over here is 80. And that means that D is 100 and B is also 100. Okay? And then that also means, due to our congruency symbols, that G is 80 and E is 80, F is 100 because E and F are linear pairs, supplementary. And then here we go over there, 100. Now you may be noticing we use two numbers for this entire picture. Here's where we get into our theorems and postulates. Whenever you have two parallel lines cut by a transversal, we can know certain things about the angle measures. For instance, corresponding angles are always congruent. And we know this by the corresponding angles postulate. Okay? Pay attention to wording back here. This is a postulate. So we can use this without having to prove it. All of these others are theorems. We're going to have to prove them first before we can use them. But going on, alternate interior angles, so B and F, or C and G, these are also congruent. And then alternate exterior angles, D and H, A and E, these are congruent as well. Your consecutive interior, or your same side, as I will often abbreviate it, same side interior, these are going to be your supplementary angles. Okay, so B and G are supplementary. Okay, A and H. Okay. Knowing these angle relations when you have parallel lines, knowing these theorems and postulates are going to be very important as we go into solving and doing our proofs. We will be using these a lot, so make sure, star them, put a neon sign by them in your notes. Make sure you know this postulate and these theorems. Okay. Using the postulate and theorems, go ahead and solve these problems in your notes. The video is going to pause. When it plays again, you'll see the answer, and I'll briefly go over it, but I won't spend too much time solving each problem directly. And here are the answers. Okay. What I'm going to point out right now is my abbreviations. Okay. You're welcome to use any abbreviations that I use. Corresponding postulate is corpos. Okay, you can see them right there. Alternate interior theorem. Alternate interior, angle theorem. And then same side exterior angle theorem. Forgot my angles. And while I notice it, I want you to notice as well. We are talking about angles. So you, one, have to have the angles, the angle symbol. And then two, you have to have whether it's a postulate or if it's one of the theorems. Okay, otherwise you're just naming a location, and that tells me nothing about the value of the angle or the measure of the angle. So make sure whenever you use these in proofs, you include postulate or theorem. Have to. That being said, let's get to the proofs. Now, before we can use a theorem, we have to prove it. So right now we're going to prove the first one, alternate interior angles theorem. Now to prove this theorem, we can use anything we've already proven and anything we already know. So we know vertical angles, we know linear pairs, we know the corresponding angles postulate. So we can use all of those things to prove this. So let's get started. Looking at my picture, I have that A and B are parallel, and T is the transversal. It's just setting up the picture. I need to get to 4 is congruent to angle 5, and that 3 is congruent to angle 6. Okay. So first, let's write our given. This symbol right here means parallel, and technically it's two sideways lines, but computers often write it like that. Alright, next, we are now told, and we now know, that angle 2 is congruent to angle 4, and angle 6 is congruent to angle 8. So let's look at that in our picture. We have angle 2 is congruent to angle 4, and angle 6 is congruent to angle 8. Now looking at these angle relations, I notice they are corresponding angles. So by the corresponding angle postulate, I know these angles are congruent. Okay, because they're corresponding angles, and due to the postulate, all corresponding angles are congruent. And now, using an old theorem, vertical angles theorem, I can connect the pieces that I have to the pieces that I need. So I can say that angle 2 is congruent to angle 5, and I can say that angle 8 is congruent to angle 3. And these are all pieces that I need. And now we have all the pieces of information that we need in our proof. I can now say by the transitive property, angle 4 is congruent to angle 5, and angle 3 is congruent to angle 6. Sign off, and we're done. We have now proven alternate interior angles are congruent, and we can use this in further proofs. Now let's go ahead and prove alternate exterior angle theorem. Again, we are given A and B are parallel, and we are told that T is the transversal. So A parallel to B, T is transversal. All right, and this is our given. Now let's look at our picture. I need to prove that angle 1 is congruent to angle 8, and that angle 2 is congruent to angle 7. Okay, now something that I noticed, because you're always trying to compare information that I have with information that I need. So I know that angles 1 and 6 are vertical. Let's just connect dots here. I know that angle 1 and angle 6 are vertical. And then I need to get angle 1 to angle 8. I notice that angle 6 and angle 8 are corresponding. And by the corresponding angle postulate, they are congruent. So I'm going to write both of those in my proof. First, I have that angle 1 is congruent to angle 6, and that angle 2 is congruent to angle 5. And this is by my vertical angle theorem. Now, the next step now we've done vertical angles, now we're going to do corresponding angles. So we have that angle 6 is congruent to angle 8, and that angle 5, it's corresponding. Angle 5 is congruent to angle 7 because of the corresponding angle postulate. It's really badass. And now we have all the information we need in our proof. We can go straight to the end, and we have angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7 by transitive. And we have now proved alternate exterior angles are congruent. All right, now that we've done 2, what I want you to do is try to do this one. Now, not only are you going to fill in the proof, I'm going to give you a warning. So, warning, this proof is missing a step. So not only are you going to fill it in, but you need to find and put in the correct missing step. Go for it. When the video plays, you'll see your answers. And here's your answer. Check against mine. If you have any questions, please ask in class. All right, now the last thing we're going to go over is a proof that is in the book but is not on this worksheet. So just make sure you find yourself a bit of room, and we'll do it down here. So this last proof is called the perpendicular transversal theorem. All right, and again, it's in the book. It's got some odd number attached to it. I want to say it's 3.5, but you can just look in the book and see it. But we're going to be calling it, for the purpose of all of our proofs, the perpendicular transversal theorem. And this states that if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other one. So we are going to both draw and prove this theorem. So first, we're going to draw our picture over here. Here's our transversal. Here are our 2 parallel lines. And the way you know they're parallel is there's going to be a little arrowhead in the middle of the line. All right, that arrowhead says that these 2 lines are parallel. Okay, if we had another line going vertically, I'll do it in a different color so you don't get confused. If we had another transversal and we wanted to show that these 2 lines, these 2 transversals were parallel, then we would draw 2 arrowheads. Okay, so that is how you mark parallel lines, is with the arrowhead. Back to the proof. We know that this is transversal T. We know that this is line L, and then we have line N right here. Angle 1, angle 2, and the transversal T is perpendicular to line L. All right, so there's all of our given. We need to prove that T is perpendicular to N as well. Okay. So, don't have a whole lot of room here, but we'll do our best. So first we have our given, which is the transversal T cuts L and N, and then we have our T is perpendicular to L, and L is parallel to N. Because I'm running out of room, I'm just going to put these down here. But in your own proof, you would still write everything in the given in this first line. Okay. Now, let's start with what we know. We know that T and L are perpendicular, so therefore I know angle 1 is a right angle due to the definition of perpendicular lines. And then because 1 is a right angle, I therefore know that the measure of angle 1 is equal to 90. And that's by the definition of right angles. Now, when I look at my picture, I see that angle 1 and angle 2 are corresponding. Therefore, I know by the corresponding angle postulate that angle 1 and angle 2 are congruent. So that's helpful. Now I'm going to pause because that's all the information that I see immediately. I'm going to pause and see where do I need to go. I need to prove that T is perpendicular to N. Well, in order for T to be perpendicular to N, that angle 2 also needs to be a right angle, because by definition, perpendicular lines form right angles. So if I can get angle 2 to be a right angle, then I can prove that these two lines are perpendicular. I already know that angle 1 and angle 2 are congruent, that the measure of angle 1 is equal to 90. So now all I have to say is the measure of angle 2 is 90, and I'm doing good. So I'm going to go ahead and go in that direction. I'm going to try and say that angle 2 is 90. To do that, I have the measure of angle 1 is equal to the measure of angle 2 by the definition of congruent angles. Now it's just substitution, so I have the measure of angle 2 is equal to 90. Now, since the measure of angle 2 is 90, I can say that angle 2 is right. It's a right angle, which is perfect, because now I can say that T is perpendicular to N because of the definition of perpendicular lines. Sign off, and we're done. This is the perpendicular transversal theorem. Alright, that's it for this video. Sorry about the long video, but it was a lot of information. If you have any questions, be sure to ask me in class.